Okay, so that leads us on to what we're looking at today. So we're looking at algebra today. So we've finished actually the main course for this year of what you need to cover. So we're going to go back and revisit some of the hard topics from earlier in the year, get the extra practice and make sure that we're confident with them. So we're going back to an algebra topic now, and we're going to be looking at simplifying expressions. Okay, so first thing to think about is what is a like term? You might have heard this earlier in the year, like terms. See if you can remember what they are, and we're going to go through some examples now. Okay, so what we've got here, we've got these first two columns here and here. What we need to decide is, are these like terms or not? So basically the key thing to deciding if something is a like term is looking at what letter it has next to it. So these two, the letter they have is A, and we don't have A squared or A cubed, it's just A. And if they're the same, if it's just A for both and there's no squares or cubes or anything, then they are like. So with these ones are like terms because they've both got the same letter and the letter doesn't have any powers for both. However, if they were both A squareds, that would still be a like term, just for future reference. Okay, so these two, look at the letter, does it have any powers? If it does, are they the same? Have a think, is this a like term? If you can remember this from earlier in the year, great, you can do this as a recap. Okay, so these two are like because they've both got A and they don't have any powers there, so we're all good. Okay, these two, have a think, are they the same as each other or are they different? Remember, they have to be the same to be like. Okay, so these two actually are unlike, and it's really important when you're doing algebra that if it's a capital, you keep it a capital. If it's a lowercase, you keep it a lowercase. Because when you get higher up in maths, you might sometimes in the same question have T, say meaning temperature, and then a little t meaning time. So for now, not super important, but it's important to get into really good habits early. Okay, minus 3a and 2a. So again, just thinking, what about the letter? Is the letter the same? Has it got any powers? If it's the same and it hasn't got any powers, it's going to be like. So this one is like, well done if you got that. Okay, what do we think for this one, 4a and 4b? This one is unlike. So even though the number is the same, the letter is different, and that's what tells us if it's a like term or not. So this is like with the chess and the gems. So if you imagine A is chess and B is gems, if we have 4a and 4b, we can't add them together. We can't add chess and gems. If they're different, we can't add them. Okay, so 3a and 3a squared. So think back to what I said earlier. Are these like or are they unlike? So actually, these would be unlike. So even though the letter is the same, it's A for both, this one is A squared, this one is not. So because we don't know what A is, we can't add these together, because we don't know what A squared is compared to A. Okay, what do we think on this one? 2A squared, 7A squared. Okay, well done if you managed to get this one. It is like, and that is because they're both A and they're both squared, so they are the same algebraic term. So the algebra part of this is the same for both. Okay, minus 3a squared and 7a squared. Okay, this one is like as well, because again the algebra part is the same. They're both a squared for both, so that one is a like term. We could add them together if we wanted. Okay, so we've got 2a squared and we've got 2a to the power of minus 2, a bit of a hard one now. Okay, these ones are unlike, so because this one, they are both a, but this one is a power of positive 2, this one is a power of negative 2. So these are unlike. And I think last one, so this is 2 to the power of a. Is that the same as a to the power of 2? No. These are unlike, and that is, they're just the different way around. So even though it's the same letter and the same number, because one of them is a squared and the other one is 2 to the power of a, we don't know that they're the same. Oh, sorry, there's one more. So x and square root of x. So these are unlike. So even though the letter's the same, we can't add them because their indices are different. So this one's been square rooted. Because we don't know what x is, we can't do anything with that. So these last three, definitely a bit harder than what we need at the moment. So if you manage to get them right, really well done. But that is extension stuff. So if you didn't get those ones, don't worry too much about that. This is the stuff you want to be focusing on, these top ones. But these bottom three, if you did get them, really good work. Okay, so what we're going to look at today is how we collect up like terms and simplify algebraic expressions. So an algebraic expression is some algebra like this where we don't have any equals, and we need to see if we can simplify them. So if we've got f plus f plus f plus f, how else could we write that? So how many lots of f have we got there? So we've got f plus f plus f plus f. We could also write that as 4 times f, because it's 4 lots of f. And when we have a multiplication in algebra, rather than writing this times, if we have 4 times f, we just write it as 4f. So that would be our answer for that one. That's not too difficult. So if you think about this, it's similar to if you had 3 plus 3 plus 3 plus 3. You could write that as 4 times 3. Same kind of idea, going from here as it is going to here. You've got lots of them added together, you count up how many it is, and that's how many times you have. One extra thing, the number in front of our letter here, so 4, that is called a coefficient. So if you can remember that word, it'll pop up all the way through school. So even when you're doing your GCSEs, that'll be a really useful word to know. Okay, a little bit trickier now. So we've got f plus 2f plus 4f plus f. So in the last one, we had f plus f plus f plus f. So each of these f's is actually the same as 1f. So we've got 1f plus 1f plus 1f plus 1f. So if you've got 1 add 1 add 1 add 1, that is where we get the 4f from. So what we can see is, because these all have the same letter, we can just add the numbers in front. So where we have f's though, we treat that as 1f. So we've got 1f, add 2f, add 4f, add 1f. So how many of these do I have? How many of the f's do I have altogether? So I've got 1, add 2, add 4, add 1. So we've got 1, add 2, add 4, add 1. So that is 8. So altogether I have 8f. So basically the key thing to remember is if the letter is the same, so if it's a like term, then we can add them. If it's not a like term, we can't add. So like term means we can add. If it's not like, we can't add. So we'll see one in a minute where we can't add. So because these were all f, we could add. Okay, so let's have a look at this. So we've got 3f, add 5f, add 2. So we can see these two are like terms because they both have f and it's both, neither of them have a power. So these two are like. This one though, it doesn't have an f. So this one is not like the others. So what we can do, we can actually add these two together and we can't do anything with this. So at the end, we're just going to have add 2. That's going to stay there. So whatever we do with our algebra, we're going to have add 2 at the end. So let's do what we did last time. So we've got 3 lots of f, add 5 lots of f. So how many lots of f do I have altogether? So 3 add 5 is 8. So altogether I have 8f. So the most common mistake at this point is to think, right, I've got 8f, add 2, that's 10f. That would be wrong. It is not 10f. And that is because this 8f and this 2, they're not like terms. Because this one has an f, this one doesn't. So even though it looks a bit weird, our final answer to this is just 8f plus 2. We can't do anything else with it because we've run out of like terms, so we just leave it as 8f plus 2. Okay, now quite a tough one. So we've got 3f plus 2 minus 6f plus 2g minus 3. So wow, this looks a lot harder. However, the idea is very much the same. So what we need to do first is identify the like terms. So let's start off just with the f ones. So we've got the f's there, so I quite often will do lines going between them to show which ones I'm combining. So here we've got 3f and we're minusing 6f. So what is 3 minus 6? So careful not to do 6 minus 3. 3 minus 6. So if we imagine a number line, so we've got 3, so we go minus 2, sorry, 2, 1, 0, so it's minus 3. We've got 3 more to go, so that'll be minus 1, minus 2, minus 3. So we've got minus 3f. So now let's do the g's. Well, I've only got one g, so that's just going to come down because it doesn't have any like terms, so we just can't do anything with it. We just leave it as plus 2g. And the last thing, we've got this 2 and we've got this minus 3. So we know how to add numbers because we've been doing that for ages. So 2 add minus 3, so that's 2 minus 3. So if we start here, we're minusing 3, so that is 1, 2, 3. So we end up with minus 1. So this one is definitely a bit tougher because we've got more than one letter and we've also got some negative numbers in there. So the key steps is only add like terms and careful with negatives. Okay, so getting back to our answer for this, so we've got minus 3f plus 2g plus minus 1. So we can see f, g and minus 1, none of the letters are the same, so these are not like terms. So again, even though it looks a bit weird, we leave our answer as minus 3f, sorry, plus 2g, and then we've got plus minus 1. I'm just going to write that as minus 1. So a bit of a weird one because we've still got algebra in our answer, but you can have that. When we're collecting like terms, you can have algebra answers, and you usually will. Okay. Okay, I went back and edited this slide, so there's a bit of a jump in the video, don't worry too much. Okay, so 2a plus 3b plus a minus 2b. So the first thing to look at is, are these all like terms? And we can see straight off that a and b are not like terms. So we're going to have to deal with the a ones and then deal with the b ones. Okay, so we've got 2a and we've got a. So if we've got 2a and we add one more a, altogether we have 3a. So we've got 3 lots of a. Then we're done with the a's. Let's skip over to the b's. So we've got plus, and then we've got 3b minus 2b. So what is 3 minus 2? So that tells us it's 1, and then 1b. So in algebra, if you've just got one of something, you don't need to write the 1 in front. You can just write it as 3a plus b. And we can't do anything more with that because a and b are not like terms. So a lot of people at this point would say, okay, that's 3ab. That is not the correct answer because a and b are not like terms. We can't add them and we can't do anything else. So we just leave them separate. That's completely fine, and that would be our final answer. So I think last example before we do a bit of practice. So we've got f plus f squared plus f plus f. So think back to the like terms section. Would f and f squared be like terms? So they wouldn't be because this one is squared, these ones aren't. So we've got f, f and f, and at the end we're just going to have plus f squared because that one doesn't have any like terms, so that just stays the same. So what do we get if we add f, add f, add f? So how many lots of f have I got? It is 3 lots of f. So our answer is 3f plus f squared for that one. So again, we can't do anything with that because this isn't a like term with this. So 3f plus f squared. Okay, so now what we're going to do 2 speed questions. So you may not be able to do it in the time. If you do have to pause the video, that is fine. Don't worry too much about it. I'm not expecting you to do them super quickly already. But if you want to try and do it in the time, that is completely fine. So you're going to have 30 seconds on each. I want you to see if you can get these ones right within the time if you can. But it's more important that you get them right rather than you do them quickly. Okay, so first question coming up. You've got to simplify it. Off we go now. about halfway through the time now. So 5f plus 5f. This one you might have been able to get quite quickly, I'm not sure. And we'll do answers at the end. So question 2 is 6f minus 8f. So be careful, make sure you're doing 6f minus 8f and not accidentally doing 8f minus 6f. So careful which way around it is. So you'll need to use some negatives here. So 6f minus 8f. Okay, a few seconds left. 3, 2, and 1. Okay, answers are coming up next. Okay, so that first one, 5f plus 5f. So we've got 5 of something, we're adding 5 of something. We end up with 10 of it. So 5f plus 5f is 10f. And this one we had 6f minus 8f. So we're going to be doing 6 take away 8, which is minus 2. And we're dealing with f, so it's minus 2f. Okay, so here's some questions now. So either you can pause the video, but I've also uploaded this to Firefly as it is, with the answers. So I want you to start at these top ones, and they do get a bit harder as you go onto the second box. So the first set of questions, the 1 to 20, they're a little bit more straightforward, but then when you go onto the second set, the 1 to 15, they do get a little bit trickier. So you can either work from the video or skip over to the file I've uploaded to Firefly and practice what we've just done. Okay, I'm going to put the answers up in a second as well. So 3, 2, 1. Okay, answers are here as well. So I think just ignore these ones in the middle. I'm not sure what these are. So you've got your answers to box 1, answers to box 2 here. So check your answers, check you're getting them right. If you are, keep going. If you've made a few mistakes, see if you can go back and see if you can work out where you might have made those mistakes.